Okay, last lecture we discussed about principle of impulse and momentum. Okay, and we can write the principle of impulse and momentum mathematical form. Then I can write mv1 plus impulse from 1 to 2 induce change of linear momentum. Okay, and note that these are vectors, and also this is a state variable. Okay, that means it describes between state 1 and state 2, right? So, for example, I think everybody did the classroom homework. For example, we have a famous pendulum, and we have another pendulum that has mass, same mass, m1, m1, and I release this from the same angle theta 0, and then it will move over there, and it will hit this pendulum. And my question would be, what would be the pendulum's velocity right after it was hit by this pendulum? Okay, then the given is a theta 0 or height, okay, and mass m1, and we want to know the velocity right after the impact. That we say V1. What is V1? Okay. Then we have a choice of 3 tools. 1, 2, 3 tools. One is a mathematical term, resultant force, induced motion of a particle. And the second principle is principle of impulse and momentum. And the third principle is principle of work done and kinetic energy, or conservation of energy in special case, or conservation of linear momentum for special case. And those are all vectors, therefore we can look at the behavior of those vectors by introducing position vector, for example, here to there. Then this will induce angular momentum. This will induce a moment with respect to that point, and so on, so on. Right? So, what kind of tool you would like to select to solve this problem? And note that this involves the force and acceleration. This involves velocity and force and time. This involves what? Velocity, displacement, right? And this one involves mass and velocity. Therefore, which one you would like to select to solve this problem? Okay, so the given height, we can obtain the potential energy taking this as a datum. That would be mgh, and kinetic energy over here would be 0. And when it moved over there, right before it hit the second mass, okay, then potential energy would be 0 because we take a datum over here. And then kinetic energy will be mv, say 2 square. Because there is no energy loss, this one and this one has to be conserved. So conservation of energy. Force. Therefore, I can write V1 plus T1 is equal to V2 plus T2. In other words, the energy at state 1, energy at state 2 must be same. Okay? This is very much related with thermodynamics law, first law of thermodynamics. What it means by first law of thermodynamics? Energy must be conserved. What is the law of second law of thermodynamics? Entropy must be increased. Right? That two law governs every thermodynamic behavior. That's fantastic. What is entropy then? That is difficult to understand. One way to understand entropy when I was a student is when you have two balls, the blue ball, white ball and the red ball, and you have in the box. Here you have white ball, and here you have red ball. As you shake the box, the white ball and the red ball will be mixed. Okay? So when you shake the box on and on, then the distribution of white ball and red ball tend to be uniform. Okay? That's one way to understand thermodynamics second law and understanding entropy. So if entropy is a constant isentropic process, that means there is no entropy increase or decrease. Entropy has to be increased, of course. Then what will happen? That is also different with adiabatic process. So in thermodynamics, they also have very different three examples, right, to understand the thermodynamic law. Same is here. So Newton's law, principle of impulse, and the energy law. Three laws. We are using three laws. And you have to understand the way to select three laws, as I talked before. Now, how to select it is much, much simpler than thermodynamic case. You just look at the variables over here. If you want to know that the variables that is likely related each of these three laws, then you just select it. So in this case, we select conservation of energy. At state 1, the energy is mgh. At state 2, energy is mv2 squared. Therefore, we know v2 is equal to square root of 2 mgh. Okay, that is the velocity of first mass just before it hit the second mass. So now physical situation is, I have a second mass over here. Okay. So I have pendulum over here, and I have another pendulum over here, and this is moving with the velocity of v2, that is square root 2 gh. This is just before impact. And just after impact, this will move. First mass and second mass will move like that. And let's say this is mv. I use the subscript v2, so I may say second mass velocity, and I said this is first mass velocity v1 after impact, Okay? Because this involves with impact, I want to use the principle of impulse and momentum. So this is a pictorial expression of principle of impulse and momentum. And I emphasize again, the reason why we use pictorial expression of each three laws is because those laws involves a vector, and the vector has a direction as well as a magnitude. Therefore, to express magnitude and direction, the best way is to express those laws pictorially or graphically. Okay?